Hello बच्चों, so let's read this question. The limiting molar conductivities of NaI, NaNO3 and AgNO3 are 12.7, 12.0 and 13.3 Siemens meter square mole inverse now respectively, all at 25 degrees Celsius, which is a constant temperature for all of them. The limiting molar conductivity of AgI at this temperature is dash millisiemens meter square mole inverse. Now, what we have been given, we can solve this question by using Kohlrausch's law of independent migration of ions. So, key concept would be Kohlrausch's law of independent migration of ions. So, the limiting molar conductivity. This law says that जो हमारी limiting conductivity होती है electrolyte की, it is equal to the sum of individual contribution of an ion or cation. So limiting molar conductivity of an electrolyte is always equal to the sum of individual contribution of the anion and the cation of the electrolyte. Now, moving on to the formula, हम कैसे लिख सकते हैं? That is, limiting molar conductivity of the electrolyte is equals to limiting molar conductivity of the cation plus limiting molar conductivity of the anion. So, over here, lambda alpha naught represents molar conductivity of the anion, whereas lambda naught C plus is equals to limiting molar conductivity of the anion. Sorry, it is not of the anion, it is of the electrolyte. Of the electrolyte. This is limiting molar conductivity of the cation, and this is limiting molar conductivity of the anion. Now moving on to the question over here, we have been given the limiting molar conductivities of the following compounds, which is limiting molar conductivity of NaI, which is equals to 12.7 millisiemens mole inverse meter square mole inverse. That's the unit that they have used. And limiting molar conductivity of NaNO3, which is equals to 12.0 millisiemens meter square mole inverse again. And limiting molar conductivity of AgNO3, which is equals to 13.3 millisiemens meter square mole inverse. तो ये हमें मोलर कंडक्टिविटीज दी हुई हैं. नाउ मूविंग ऑन, अगर हमें निकालनी है AgI की मोलर कंडक्टिविटी, तो हम इसको ऐसे भी लिख सकते हैं, लिमिटिंग मोलर कंडक्टिविटी ऑफ NaI is equals to limiting molar conductivity of Na plus ions plus limiting molar conductivity of I minus ions, which is equals to 12.7 millisiemens meter square mole inverse. And also we can write limiting molar conductivity of NaNO3 as equals to limiting molar conductivity of Na plus ions plus limiting molar conductivity of NO3 minus ions, which is equals to 12.7 0 millisiemen meter square mole inverse, and also limiting molar conductivity of AgNO3 is equals to limiting molar conductivity of Ag plus limiting molar conductivity of NO3 minus ions, which is equals to 13.3 millisiemen meter square mole inverse. Now, we will mark this as equation 1 and mark this as equation 2 and mark this as equation 3. तो अब हम इससे क्या करेंगे? We will just perform. We will adding equation. देखो अब Ag और I किस में है? आयोडीन हमारी इक्वेशन 1 में है और Ag हमारा इक्वेशन 3 में है, तो हम इन दोनों को तो ऐड कर देंगे इक्वेशन 1 and 3. And the unwanted stuff from equation 1 is Na and unwanted stuff from equation 3 is NO3, जो कि दोनों हमारा प्रेजेंट है इक्वेशन 2 में, तो हम सब्ट्रैक्ट कर देंगे इक्वेशन 2 and subtracting equation 2 from it, right? So now let us further move on to the question. हम सिर्फ इक्वेशन सॉल्व कर रहे हैं, so that would be equals to limiting molar conductivity of AgI is equals to 12.7 plus 13.3 minus 12. 12.7 plus 13.3 minus 12. So जब हम इसे सॉल्व करेंगे it would be equals to 26 minus 12, that is equals to 14. So हमारी limiting molar conductivity of AgI यहाँ से आ जाती है 14. So that will be the final answer to the question. Final answer. Limiting molar conductivity of AgI is equals to 14 millisiemen meter square mole inverse. That is the answer. I hope you understood the question well. Best of luck.